Hi, this is Josna. Welcome to Josh Tutorials. Today I am going to say something about NLX method, which is very used in writing the electronic configuration of an element. First, let us see what NLX means. N, the principal quantum number, denotes principal quantum number. L denotes the angular quantum momentum or azimuthal quantum momentum number, and X denotes the number of electrons present in it. This is the way we determine the electrons and the orbit and the angular momentum of the particular atom. And how we are going to write this? Look at this modern periodic table. Just now I am going to take the first group elements, that is hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Look at this. I am going to write NLX method for this. Hydrogen 1s1. Hydrogen 1s1. 1 denotes the principal quantum number 1, S denotes the azimuthal quantum, and 1 denotes the number of electrons in that particular shell, 1s1. Whereas coming to lithium, it is 1s2 in 2s1. That is, the first orbit is completely filled and the electron has entered into the second, and in it is only one electron, 2s1. And sodium, it is 1s2, 2s2, 2p6, 3s1. The electron entered third orbit and only one electron is there in that orbit. While coming into potassium, it is 4s1. Again, in the fourth orbit there is only one electron, that is in s orbit. And again it is 5s1. By looking at this, we can say that all these orbits are having one electron in their outermost orbit. So this can be termed as NS1. N is the principal quantum number and S is the shape of the orbit, spherical, and in it there exists only one electron in it. So, in other words, we can write this as, with the help of noble gas configuration, like this. And when we see the electron revolving around it, for hydrogen, it is in the first orbit one electron, and for us lithium, it is the electron in the outermost orbit one electron, and for sodium, in the third orbit there exists a single electron. Likewise, we see for in the fourth orbit there exists only one electron, and for rubidium, in the fifth orbit one electron is there, and in the cesium sixth orbit one electron is revolving. In the outermost shell we are able to see only one electron, so we can configure it as NS1. Similarly, when we look at the modern periodic table and take the second group elements from beryllium to radium, we can see that it is beryllium, it is helium and 2s2, and for magnesium it is neon 3s2, calcium argon 4s2, and for cesium it is chromium 5s2, and for barium it is xenon 6s2 and for radium it is radon 7s2. And again, if you look at this modern periodic table, if we take the 13th group elements, that is p orbit elements, from boron to nihorium, it exhibits helium 2s2 2p1, neon 3s2 3p1, argon 4s2 4p1, krypton 5s2 5p1, xenon 6x2 6p1, radon 7x2 7p1. We can observe from the last two columns, we can say that the group can be said as ns2 np1. Similarly, for the modern periodic table, we can say that the first group elements can be said as ns1, second group to be ns2, and the 13th group to be np1, 14th ns2 np2, 15th group ns2 np3, 16th ns2 np4, ns2 np5, and the last and inert gas elements to be ns2 np6. That's for today, and if you like this video, please share it to the needed students, make them subscribe and post a comment of your name.